So, welcome everybody from section 2. So I'll wait a couple of minutes to let people filter in. But while we're waiting, how did everyone find the second assignment? Any comments before we dive into it? Yeah, Mehdi mentioned and Albina. Are these the yeah, Mehdi and Albina mentioned that they were a bit confused as to what was actually asked for. Were there any questions in particular that were more confusing? Or question 1 or 2, which one was more confusing? The first one. Okay. Yeah, the first one was meant to be more in the style of the first homework, where there's part of the assignment is really um, it's a bit challenging to like part of the assignment is to try to find a way to solve like a more unique problem. So moving beyond just simply make an aggregation, aggregating x and y. So hopefully it'll make more sense with when we go over it here. And as we go over it, we'll feel free to talk about what sort of approach you chose, and we could talk about various approaches, because obviously with these sorts of questions, there's there is it's a bit more open. Like there's no sort of strict right answer. It's like what I'm just really looking for is that there's you're sort of addressing the like each question. There's pretty much a sort of a core sort of an objective that you're looking to um, that you're looking to solve, or some sort of objective that you're working towards. And there are multiple ways to get to that objective. So it's and Mehdi, yep. So and Mehdi mentioned that that you're visualizing the first three types of heights. So that's absolutely valid. Like and little things like that, like whether or not you're including which height categories, in this case you're including. I'm not too worried about things like that, but I explicitly mentioned in the question that I wanted to look at these different category, sort of groupings of floors, and trying to sort of draw conclusions from that. And then Mehdi added the that you're looking at the highest construction years. What do you mean by highest construction years? Like highest construction meaning like the most number of buildings built in that year? Okay. The so that kind of gets at it. The and I'll so actually let's just get started, and maybe I'll sort of address your comments as we go along. But yeah, so it's like I'll have to see what you ended up doing, but it's you don't want to look at just the year with the highest constructions, because we're sort of looking at how buildings are built over time. And hopefully that'll But you do get some information, like for instance, as you're looking at buildings over time, the rate of building increases. So you are able to sort of arrive at like when the first you know sort of when buildings of certain heights were beginning to be built. So with that, I'll just get started with going through the assignment. The first the first thing that we had to do was try to figure out what exactly was happening with the data. So when we just plot it out naively, we're looking at year built, and we're just simply aggregating by individual years. We end up with something that looks kind of weird. We have these spikes, and it's not entirely sure what's happening. So what did people think was going on here? Yep, Albina. So this is data quality. More specifically, what do you think? What do you think this was a result of?
Hi. Um, I think the description of the year in data dictionary specified that some of the dates were only correct for the decades as opposed to the year itself. So even though it could have said that it's like 1921, it could have really fall in the 20s decade, but might not necessarily be in the year 21. I think if I remember correctly, I'm just trying to look for my notebook right now myself.
Yep, and that's absolutely correct. That is a data quality issue, and what's happening is for older buildings, we don't have as much information about those buildings. So we may not, we may know a building was built in the 1920s. We don't know when exactly it was built, and that's why we're getting these. Albina, that's a good catch that it was mentioned in the data dictionary itself. Like this was just sort of, by noticing that, you have 1910, like 1915, etc. And you have these different, sort of these different spikes. So the first thing that I ended up doing was just getting a more detailed look at the buildings over time. And actually, Albina, I see, couldn't correct for outliers. What do you mean by outliers?
So again, in the data dictionary, they mentioned that 1910 and 1920 were outliers, I think, where the buildings from prior years ended up in those decades. So I wasn't really sure what to do there instead of just like being them in decades, but like I didn't correct for that point that was specifically listed. And
Yeah, and that's pretty much the best that you could do with a data set like this. Like this happens to be not the cleanest data set, and you have, so like binning over 10 years or, either 5 or 10 years, and, that solves sort of the majority of the issues that you have. And there's, not much that you could really do for the outliers. So, we sort of end up with, some potential data problems there. Although looking at, now that we're, in this case, it's binning by 5 years. So, there's still some fluctuations happening, but it's definitely not, so I wouldn't want to, take this as, absolute truth, but it's, still gives us a better idea of the trends of what's happening. So, when we're looking at number of buildings built over time, you're able to sort of see that, you have the trend go up. You have more buildings being built during this sort of 1920 to, in the 20s and 30s, ending around the Great Depression, and then you sort of level down. And, there's a bunch of reasons for that. Really, like you have the Roaring Twenties, so that was an economic boom time before the Great Depression, and you also have the fact that New York was just a younger city back then. So you have more room to expand. Whereas even in, more recent booms, you don't have that degree of new construction. So looking at it, in this case, I chose 5 years, but 5, 10 years, any of those are okay to use. And this looks a lot better. So, we're able to, again, get, more of a handle on the patterns of, buildings here. Albina is asking if I'll be sharing the solutions. I think what I'll do is I'll just upload them. I might just upload them to Blackboard. Um, I I don't really want to add them to GitHub because like once you add them to GitHub and then in sort of future sessions, even if you remove them, like smart students could just simply look at the commit history and see it there. So
Okay.
I'm sorry.
Or maybe you can just send us like those, like, the code snippets. Because, for example, I've noticed that you use resampling. I couldn't get resampling to work on something like that. So it would be just, and since you're kind of showing us diagram itself, it's not like I only caught a glimpse of it. I didn't exactly see how you did it. So
Yeah,
that's why.
definitely. Yeah, and I actually meant to highlight that. So thanks for reminding me that so in resampling this, like you could use like Pandas has a lot of built-in functions for dealing with different data types. Like in this case, time series, sort of data. It's good at dealing with that. And here, so what I did was, just make sure that it's date time and then I'm using this resample function, which sort of functions as a stand-in for group by. So all I'm doing is with resample, I provide it a frequency. So I say I want it every 5 years. There's codes to like 5A, 5Q for 5 quarters. And this is useful for when you have data such as this, where you have timestamps and you're looking to sort of aggregate those timestamps in however way you want. So I'll definitely find a way to share these. So using resample, that's just using a pandas built-in function, which is pretty neat, and you end up with something like this. And now to get a bit more closer to, and actually, just to start out like looking at the same just summary, like here we're looking at number of lots built over time, but an alternative way of looking at how our buildings are built is to look at a cumulative sum of building. So basically, it's the same data, obviously, as something like this, but we're showing it in a cumulative way rather than just looking at what was built over time. So this is another way of dealing with the resampling problem. So like rather than having spikes like this, you have a sort of stepwise function, which is still annoying, but it's actually, it doesn't detract that much from sort of, looking at things in a cumulative way. It's easier to deal with, like visually to deal with these sort of step issues than it is to deal with a bunch of spikes. And something like this, you're clearly losing the underlying pattern, whereas here you're preserving that pattern. And so this is a good way of seeing that. And so that's one way of viewing just construction over time. But this is also a good way of answering the of like arriving at our objective. So we're the sort of question that we're looking at, we want to look at buildings that were unusually tall when they were built. And, so the sort of things we want to look at is, look at buildings being built over time and, trying to see, like, a building would be unusually tall when it was built if it were the first, one of the first of, its type of buildings being built. So I, mentioned here bin year buildings in terms of, 20 to 29 stories, 30 to 39 stories. So if you're looking at each of these bins and you're thinking, when were the first couple of 20-story buildings built? Those are the ones that you're going to want to keep track of. And looking at things cumulatively, this allows us to, so one thing that I purposely didn't include in the question is I didn't really include a cutoff. So, if you're looking at these different buildings, you could set the cutoff wherever you want. You could say, I want to, look at the first, 10% of buildings that, the first 10% of, 20 to 29 story buildings, and look at those, sort of treat that as my cutoff date. Perhaps I want to look at the top, the sort of first 50%. And I'm able, using the cumulative graph, you could pretty much set it wherever you want. Like if you want to look at 20%, we're looking at the 1920s. That's when we broached 20% of the buildings that are currently built in New York. If I wanted to get 50%, I would be looking around the 1930s. And these are for all buildings grouped together. And then if we wanted to, and then to get at the question, what we're doing is to group them by building height. So what I did here was just simply add a variable that is going to, sort of map these onto different, different stories. So, here we have num floors, and I'm just, sort of finding a way to get this by 10. And then I just have this here where I'm like setting my cap at 50 story. So Mehdi, you mentioned that you chose, you just looked at the 20, 20s, 30s, and 40 stories. That's totally fine. It doesn't really matter like which groups you ended up choosing. It's more, just simply that you were looking at these different these different increments. And so what I ended up doing with that was using Plotly, like if you're comparing all of these, these building types, you're adding, most of the time you're adding like different traces to a graph. So I'm just using a for loop to loop through all of these different levels. And so you could see sort of the structure here. I have, which group I'm using. And once I build that, and actually, I'm sorry, yeah, and what I'm building here is I'm using what are called subplots in Plotly. So this is pretty much Plotly's version of facets. What you would have is facets in ggplot. And with Plotly, you're just simply building the traces as you as you would if you were just adding everything to the same plot. But you have these different axis types. So I have 6 groups. I'm going to look at these. So I'm going to add each of these traces. Where am I? Yeah, so here you could see sort of where I'm like appending each of the traces, and then I'm setting separately what the axis is. So you have this when you make the subplots, you're building a Plotly figure, and you're sort of mapping these to the various subplots. So this was one strategy. Obviously, there are lots of different ways to approach something like this. But when you look at something like this, we have our different stories here, and we're able to look at graph similar to this in a comparative way. So doing the same thing that we did before, we'd be able to sort of look at, how, sort of where we want to set our cutoffs and how, sort of which buildings to choose. So if we're looking at 20-story buildings, for example, we may want to set our cutoff at 25%. And if we wanted to do that, then we have our cutoff around 1941. So if I were a building inspector, I would say anything built before 1941, we're going to prioritize for inspection and make sure that it's sort of up to code. Whereas these later buildings, we don't have to be as worried about them. For 30 stories, you have, if you want to sort of use that same cutoff, you don't reach that 25% threshold until the 1960s, until 1967. So similarly, I would, sort of use that as my cutoff, check buildings that were built before this time period. And the cool thing about using these cumulative plots is it lets you pick, any sort of cutoff. But like with any, like with a lot of questions of these types, there's lots of different ways to approach them. So, there's definitely other, other approaches that would work here. Any questions about what I ended up doing here, or anyone want to share what they ended up doing?
I feel like I didn't solve the question because I didn't go into such details, and I mentioned it earlier in the chat. After reviewing the materials, I saw that you had the 2D histograms and heat maps.
Yeah.
And I basically just ended up plotting the heat map where I didn't even bin them. But my reasoning behind that was that over time, even though the mean height of the building kind of stayed the same, I've noticed that median increases. So I wasn't sure, what's the best strategy to cut them off while they increasing with each year, like the median height. So instead I just did like now, I can show you if you want, but as I said, I don't think it solves the question now that I watched you present your solution.
Yeah, definitely. So Albina, I'll make you presenter, and then Mehdi, I'll make you presenter next, and we could talk through a few of these. And apologies, but if you guys could keep it, don't keep it a bit brief, because I do have some other stuff I want to go through.
Okay.
Cool.
Yeah, but this, can you see my screen?
I can. Yeah.
Yeah. So basically, I first looked at, as I said, at the mean height of the buildings for all the years, as well as the median. The blue line is the median, and I saw how it increases.
Yeah.
And I wasn't sure how to choose it, and I did bin it in groups of 10 floors, just in case you wanted to see. I don't know if you were looking for us to learn how to bin, but yeah, I ended up basically just unbinning it and just showing it this way. And here it's kind of consistent, where you see the areas in red, right? This is where the most construction is happening, which is in the very low floors. And basically above kind of that red area, anything is kind of not very usual, I guess, or not very common. So the further it is, the higher it is in each stack, the most unusual it is, I guess.
Yeah, no, and that's and this does somewhat get at this does get at what when buildings of certain heights were first built. So for example, looking at a visualization like this, you're able to pretty clearly see for example, when elevators started coming around, and you were able to build above certain just sort of you got past that limit there. So this does give you like, sort of, some guidelines as to what to check. And so, this is, yeah, definitely like another approach to see something like that. And then Albina, so I'm going to give presentership to Mehdi. So Mehdi, you should be able to just click on the play button.
I don't see any play button.
Oh, weird. It should be like on.
It should be a pop-up.
Yeah.
No, I didn't
in
see any pop-up.
Huh. Let me try again. So I'm going to make myself presenter. And then I'll try to make you presenter. Did you see something now?
I don't think it said that you're not sharing your screen, so I don't see anything to share. That should be fine, probably. That's
okay. Yeah, so I'll take a look at, Mehdi, I'll take a look at what you ended up doing when I check the homeworks. So
okay, that's fine.
cool. So, and it's already 8:13, so I ended up trying to fit in a lot for this lecture. So for section 1, I think I made the last part push back to 2 weeks from now. So for part 2, we're looking at Datashader. And Datashader, like as I mentioned here and last week or 2 weeks ago, it's pretty much algorithmically dealing with all of your data points and smartly, sort of dealing with it. So if you do have a high density of points, it'll begin sort of coloring it and make it behave more similarly to a heat map. So this is actually looking at the same sort of visualization that we were looking at before and what Albina showed us, but this is using Datashader. So we have, the Y, we have like that huge cluster of points with smaller building that we're able to see here. And, it's truly a hybrid because you have these, but then you also have individual points when you get into the sparser regions. And so the question here was a bit more straightforward. It was, this was really an exercise to just get you guys exposed to Datashader and to, to sort of also provide a unique, way of looking at choropleth map. So here, this bivariate choropleth map, I thought was sort of a unique visualization concept. And what we're looking at here, so we're sort of flipping things around. We're now pretending we're real estate developers, and we're researching potentially underbuilt, undervalued areas of the city. And within the Pluto data, you have two parts of the value of these lots. You have the assessment of the land and the assessment, and actually I just realized when I was looking at this last section, I mistyped here. I meant to say assess total. Was anyone confused with the type of assessment to use? I mentioned that in the chat. Albina, I'm so sorry. I didn't. So did you end up using assess total?
I ended up taking the difference, yeah, the total and land.
Oh, perfect. So yeah, that's exactly what I ended up using, what I ended up doing here. But apologies for the confusion there. I meant to more explicitly state that assessment structure is coming from the total and the land. So the first thing I'm doing is just simply using the difference to get the assessed structures. And we're using this bivariate scale to sort of compare these two scales at once. So, we want to look at, where areas where we have high land values, but low structure values. Those are, like, as a real estate developer, you may want to get at those and, put the land to higher use. So we're looking at, like, assessed land versus structure, and also one of the things that this approach allows us to do is and actually someone from section 1 mentioned that they were able to so an approach that someone from section 1 ended up doing was they had a ratio here. So rather than choosing the bivariate method, they just simply had this ratio, which, it's valid. It definitely gets you sort of a comparison of where structures might be over or undervalued. But I thought, and it might be something that Datashader added the ability to do, which is to basically map a variable to a numeric scale. And when I first put this together last semester, and when I was putting it together then, I only really saw the ability to map a variable to categoric variables. And I thought that was by design, because and I sort of mentioned this last lecture, that if you look at this plot here, you have, the data is mapped to the point density. So we have denser points where we have, in this case, more lots, more single-family homes, and you have less dense points where you have more apartment buildings. And I thought it was by design, because if you could sort of see the problem with when you have a numeric variable like this, and you're adding on an additional numeric variable, and you're not doing it in a smart way like a bivariate, scale like this, but you're just simply, asking something to automatically deal with two numeric color scales. And, that's not really smart to do, because if you, unless you're, really thinking, like in this case, this guy's really thinking about these color scales and making sure that they work in a bivariate way. But if you're just throwing these at an algorithm to, an algorithm like Datashader, it's, like you could see how these color scales could kind of conflict with each other. Did anyone end up mapping their variable to, or mapping to, like, a numeric variable of like either a ratio or, assess land or assess structure? Categorical, yeah. Okay, so that might have. I'll have to see what this one student did there.
I never found that bivariate parameter like they could specify. So I ended up doing. I tried to do a stack, and in that case, the upper one hides the lower one. But so I ended up doing a ratio and rendered based on that ratio.
Okay, and I'm sorry, who's this? Oh, that's Mehdi, right? Yeah. So yeah, so I'll have to check out what you did also, Mehdi. Using, like I said, using a ratio, that's totally valid. But I want to see if Datashader added the ability to map to a numeric variable, because that would be pretty interesting if they did. But what so what I ended up doing was, and like what I was kind of, sort of trying to guide people towards, was just simply treating this as a categorical problem. So even though technically, like we're dealing with two, we're dealing with two numeric scales, if we sort of treat it pretty much taking, exactly what's recommended down here, we could treat these as categoric variables. And so when you are treating these as categorical variables, and you could sort of see what I did, like I just ended up using percentiles. So just making sure that I have an equal number of buildings within each bin. Either way, any way you guys chose to bin them is fine. It's pretty open-ended in terms of that. And what you end up getting with that is this. So I get this sort of assess all three tile, and I'm mapping that to this color key. So basically from this point, once you get your data shaped in the proper way, it'll look almost exactly the same as the racial maps that we saw with the data shader example. And all you're doing is you're defining what you want those colors to be, and data shader is going to handle the rest. So what you end up with is a pretty cool visualization, something that looks like this. And so what this, and again, like data shader is not really good with labeling things. So it's like I just sort of had a comment here so I wouldn't forget which is which, because especially with a bivariate scale, it's hard to sort of keep that in your head. But so you end up getting some pretty useful information. So you have things like in most of Manhattan, you have it's already pretty far built. So you have high land values, you have high structure values. So that's indicative of like areas that are properly built. And similarly for some of these white regions, so areas of like northern Bronx, like some areas of Staten Island, like this area here of Queens. You have areas. Albina mentioned she created a legend with bokeh. I haven't delved too deeply into bokeh, but I'll have to see how because I remember when I was first looking at data shader seemed pretty separate from bokeh. So, but it will be interesting to kind of see what was happening there. But so yeah, you're able, using this scale, you're able to, see like areas with high structure and land values, see areas with low structure and land values. So areas that, it might not make sense to build more. And then you have the, edge cases that you're more interested in. So green areas are where the land is worth more, but structures aren't worth as much. So sort of northwest Queens, this area of Brooklyn here, actually most of Brooklyn, and then conversely areas where the structures are worth a lot, but the land isn't worth as much. And so you have this sort of zone here where that's happening. And yeah, Albina, you're absolutely correct that if you're looking at these as ratios, you lose a bit of information because for example, these white areas and these maroon areas, they in terms of ratios, they would come out looking the same because you're not really looking at the absolute value of the value of the structures and value of land. You're looking at the ratio, and if they're both high or they're both low, they're both going to have sort of one ratios closer to one. But again, that's totally fine for the purposes of this assignment. And yeah, so that's what you end up with for data shader. So I'm running out of time here, so ask any questions in the chat and I'll address them sort of as I'm moving on. But I'm just gonna start kind of going through some content here. So, and actually first what I wanna do is take a look at a few sample Shiny apps. So starting now, we're getting into building more interactive visualizations. And what that means really is we're building interactive, we're essentially building web apps. So like for this module, we're working with Shiny. For module 4, we'll be working with Plotly Dash. And then and then after that, we're going to be getting into D3, which is pretty much raw JavaScript. And so as we're moving into these realms, we're starting to get sort of like surfing the boundary between data science and web development. So it's even though for Shiny and Dash things are abstracted enough where you don't have to pay too much attention to a lot of these concepts, it's still good to know what's happening behind the scenes with these sorts of frameworks. So first we'll just look at a couple of sample Shiny apps, and then I'll get into a few of these like broader concepts. So just to sort of look at the app first, what I have here is an app. We have a few controls. So we have 3 drop-downs. We have a graph here. We're looking at housing prices across different metro areas. And we're able to select, and actually before I do this, I'm going to show you guys what the data looks like. So the data that's coming in, we have time series of housing price indices across different metro areas, across different tiers, and seasonally adjusted and not seasonally adjusted. And so we have like our nice tidy data frame here, and that's pretty much what the drop downs are referring to. So when we look at this, we're sort of mapping our date to the x-axis, mapping the actual values to the y. We're sort of on one plot comparing all of the different tiers, and we're allowing users to select different metro areas and get different sort of visualizations based on what they select. So you're able to pick whether you want seasonally adjusted or not seasonally adjusted, and you're able to pick these different metro areas. And there's also a separate dropdown here that's selecting housing tier, which might sound weird because you have here all tiers being shown. But what this is actually doing is it's giving us a summary of the data for a particular tier. So when I select these different tiers, you're able to see just a summary of what's happening there. So that's the, and again, like just sort of stream questions in chat if you have any. So that's what's happening with the app. We're sort of filtering with all of these variables. It's nothing complex, just data frame filtering. And now let's see what's happening behind the scenes. So Shiny, the structure of Shiny, it's always very similar. You have 2 main components. You have what's called a UI component and what's called a server component. The UI component is what's, as the name suggests, it's sort of defining what the layout, the user interface is going to be. So Shiny has a lot of built-in concepts, things like fluid page to wrap everything up in. You have your header panel, a sidebar, and a main panel. And these are corresponding, and then within these, you have other elements. So you have within the sidebar, that's where we had the drop downs. We have 3 elements for 3 drop downs. That's called select input. And select input is we're basically just giving it the the values that it's allowed to choose. So I'm just using unique to get the unique values to choose. And we're using these select inputs to define our dropdowns. And then we have a plot output and a verbatim text output. The plot output is just receiving, in this case, a ggplot and displaying what that is. And verbatim text output is just basically showing whatever would be printed in the console. And just take another look at the app. You sort of see all of that inherent in the app. So we have plot output, verbatim text output, plot output, verbatim text output, our three select inputs, seasonality, metro, housing tier, seasonality, metro, housing tier. So we have everything pretty much laid out like that. And then the real magic is happening in the server object. So the server object is a function of input and output. And actually, one more thing to note about the UI. For each of these sort of interactive objects, so for the select inputs, for the plot output, and for the verbatim text output, we have the first argument, which is a tag or ID for the element. And it's using this ID that we're able to access the element when we get into the server object. So basically, you're accessing the output just by, you have this sort of output plot one that's referring to this label here. And then you're referencing input. So we have input, seasonality and or C's, and that's referring to this input here with the C's ID. So let's look at what we're doing here. So for each of these output types, so for plot output, we have a corresponding render plot. For verbatim text output, we have a corresponding render print. And this is similarly for other types of input and output. So as an example, Plotly has its own Plotly output and render Plotly, if you wanted to use Plotly and Shiny. And we, so that's what we're sort of putting in each of these output objects. And so we're saying this plot one, we want to sort of run this block of code. So you're using these brackets and you're just sort of having a freeform block of code in there. And that last line of code is what's being returned to the output. So it's pretty straightforward what we're doing. All we're doing is filtering the data frame by the provided seasonality and by the provided metro area. And we're taking that slice, graphing it out, and returning this graph object. Similarly, for the render print, we're taking these, we're sort of filtering by three things this time because we are taking into account the tier. But once we filter, we're just doing the same thing. We're returning this df slice. And so that's what's happening with the server, sort of server object, sort of feeding the app logic. And when we run it, we sort of get an idea of how things are being filtered in that way. And so I'm gonna get to this in a, and actually, yeah, I'm gonna, this example here, it's using, and actually, by the way, I will include a link to this in the content, but this is going through, the basic parts of a Shiny app. And this is also towards the bottom, it'll get into the reactive framework, which as apps are getting more complex, reactivity allows you to more efficiently organize your apps. So, so when we, so here in the second example, if I run this app, on the surface, it looks exactly the same as what we had before. So we're selecting our seasonality and metro area, and sort of changing what our outputs are. And it's mostly the same, but one thing that I've added here, so the layout is exactly the same, but I added this block of code here. And what I'm doing is, this is called a reactive code block. So in this selected data, I'm taking the seasonal adjustment and the metro area, and I'm making, sort of pre-filtering that, and then feeding that into other elements. So here, this output plot one, and this reactive function, like what it does is it renders as a function. So when I run selected data, what I'm actually doing is returning the output of this reactive block here. And so I'm, in one step, I'm filtering by seasonality and metro. I'm using this selected data, just returning the plot, because as I mentioned before, the plot is only listening to these two dropdowns. The plot itself is not listening to housing tier. But in the stats, I'm doing this additional step of filtering by the tier and returning that same summary of the tier. And the reason why I'm doing this, and this is sort of a summary of the app architecture as we had initially. So initially, we really just had inputs tied to outputs, and we, housing tier is only affecting the info box, seasonality and metro. They're both affecting both the graph and info box. So, you could sort of visualize the architecture as looking something like this. When you add a reactive block, you're kind of organizing things. And so what we're doing here is we're sort of realizing that this info box, perhaps we want to keep that a bit separate from, housing tier, we want to keep a bit separate from seasonality and metro area. So, seasonality and metro area is affecting the reactive block, and then the reactive block is feeding both the graph and info box. And organizing things in this way, it's a bit clearer what's going on. I mean, this app is still pretty simple, so you don't really need it. And for the homework assignment, you're not gonna need, you're not gonna really be building apps that are as complex, that you would need the reactive block. But this is something good to keep in mind, like perhaps as if you choose to use Shiny for your final project, you may want to organize things using these reactive blocks. And then, so to move on, and again, like ask questions in the chat. Sorry for sort of just barreling through everything here. But so to move on from there, I want to just talk a bit about like some broader web development terms. So, right now we're sort of just entering this world, and these are concepts that you're not really coming across using just Jupyter Notebooks or RStudio. So, whenever you're sort of looking at a web app, you could divide it into like two sides, what's called the client side and the server side. And the client side is really everything that's happening on a user's computer. So it's what's being rendered in the browser, and the language that's being used there is JavaScript. So a lot of browsers are running JavaScript, and you're able to sort of run those JavaScript functions fully on the client side. The server side is everything else, and sort of tautologically what's happening on the server. And this is things like if you're reaching to a database to get something, or if you're using APIs, those APIs would be considered the server side. APIs being like if there's some sort of service that you're pulling in data, you give the API parameters, it spits out data, that's sort of going to the server side. If you build a web app on top of that, the web app is sort of using it in the same way that you are. So that's the rough division there. And to sort of look at what Shiny is doing, if we're like when we run this, we have, like this is, you could consider it a browser. Shiny apps you're able to access in any browser. So this is, so what's rendering here, this is your client side. But the server object, like, we're using we're using the R language to filter this data frame. And so and sort of looking at what I mentioned happens on the client side, that's not JavaScript, that's happening within R. So you're not really you're definitely not interacting directly with it, but what Shiny is doing is Shiny is spinning up an R server that, as well as sort of a front end that's accessing that server, and it sort of builds this web app for you, like when you provide this information to it. So it's saying like, I'm going to render it using these instructions provided in the UI, and on the server side, whenever events are triggered, I'm going to go back to my R server and I'm going to run these R functions. So, we're just filtering data, but these things could just as easily be, running in an OLS model and returning a best fit line, something like that. So, so like Shiny, like it's doing a lot for, sort of abstracting a lot and, allowing users to really interact with it using just R. So going back to our model here, we have kind of, the server side, that's R, that's our R server that's being spun up. And the client side is what's happening in the UI. So it's rendering sidebar, the plot, the, everything that we want to render in the browser. So I think, I stopped here for the last section as well. I was a bit ambitious about what I wanted to show, but this is good because for our next meetup, we'll, pretty much for the rest of the course, like Shiny and Dash, these are both abstracted, tools to build web apps. But especially when we move into D3, we're going to be like, more low level, and it'll be helpful to be thinking about these sorts of web development concepts. And so, with our next meetup, this is sort of a hand-wavy thought experiment. So I'll, sort of guide us through, what sorts of things you would think of if you were building a web app from scratch.
Is it possible to publish Shiny apps through a web server, like a regular web server, ISS or something like this?
Yes, and actually I forgot to mention this in the, I forgot to mention this in last section, but for module 3, the apps must be deployed, and so what you'd be using is shinyapps.io. They let you create free accounts, and it's very simple to deploy. Like you pretty much just, have your file and you send it off. So it's a very painless process. And this, of course, helps me in grading because I'm able to just see a URL with your apps. And Peter, I'm sorry.
Yeah, my question was like, if I have my personal web server, like personal server, can I publish an application through that instead of going through this?
It's
like, is it possible technically?
Yeah, it's technically possible, but it is more difficult.
Okay.
And I actually haven't tried that personally. So, like basically when you, and you'll notice this with Dash as well, like Dash is more low level than Shiny, but, because with RStudio, you sort of have this like run app thing here. But what's really happening is like this is the function that is running running your app. So when you click on run app, you'll notice that the console hangs here, and that's indicative of the fact that you have a server running. If there's any logs, if you run into errors, the errors will appear over here. But basically the running of the server is a continuous process. And so like Shiny is like any other web app. You could run that process, allow it to be open to the internet, and host it yourself. I personally haven't really done that, but if you want to try that out and you get it working, then absolutely go for it. But Shiny apps, but for every, like if you're not able to get that working, and or for anyone else who doesn't want to be as ambitious as that, Shiny apps is a pretty turnkey solution for deploying things. And yeah, Peter, I'm interested in what you mentioned. So because this was something I was thinking of with Datashader, where so were you able to like get this experience where you could sort of zoom in and have the Datashader app re-rendered? Cool. Yeah, because the way and just to give you guys a preview of what'll be coming next week, like I was thinking of associating it with it's that sort of concept of zooming in, having that re-render. It's very similar to and comparable to what happens with something like Google Maps, where you have a slippy map, you're dragging it around, you zoom in, you're at different levels of zoom, you're able to see different things. And so like what this thought experiment is meant to do is sort of, and this has always been like a project I've wanted to, try to spin up whenever I had the free time. But it's, but I think it could be a pretty cool, a pretty cool sort of thought experiment to help get everyone acclimated with the sorts of things that you would think of in building a web app. So stay tuned for that. And so any other questions on sort of what we have ahead for Module 3 or anything else we covered? Albina asked if I could confirm meetup dates. The meetup dates should be in the meetup info link. So in Blackboard, if you click here, you'll see all of the, like they're every 2 weeks, and you'll see the, you'll see sort of the dates there.
It looks like the next one we have is October 1st, which is like already next week, right? And then there's like a 3-week gap.
Oh, that might be a mistake. Yeah, Albina, that's a good point. Let me make sure. I probably just made a mistake there. So,
And also for November, it seems like there are like only a couple of meetings. Well, oh yeah.
yeah. So, yeah, thanks for the catch, Albina. I am just not having good luck with meetup logistics at all this semester, but I'll definitely verify that, and I'll put out an announcement if, and I'm pretty sure that needs to change. I'm pretty sure that's just going to be the 8th, right? The 8th, yeah. But I'll get the correct date there. Cool. All right. So thank you everyone for attending, and good luck with Module 3. Good night, and yeah, talk to you guys probably in 2 weeks. Have a good night, everyone.
Okay, thank you. Bye.
Bye.